In this video, we are going to study operations on signals and that too on independent variables. Therefore, here the independent variable is our time parameter. So we are going to study different operations on the t parameter of signal. The first operation that we are going to study is folding operation. It is also called as mirroring. So if we have a signal x of t, then its mirrored version or folded version, so instead of saying mirroring, we will follow the notation of folding. If the folded version of this signal is denoted as x of minus t. So we are multiplying the time coordinate with minus t. So to take an example, let's say we have a unit step signal u of t, which is having amplitude 1 from 0 to infinity. And now if we want to find out its folded version, this is our time axis, and now its folded version is simply computed as, we are going to keep mirror on y-axis and it will be a two-sided mirror. So whatever we are going to see in first and fourth quadrant will be folded and drawn in second and third quadrant. Similarly, if we have any signal in second and third quadrant, so second quadrant signal will be folded and it will be drawn in the first quadrant. Similarly, signal in the third quadrant will be folded and it will be drawn in the fourth quadrant. Therefore, if we fold the signal u of t, which is available only in the first quadrant, keeping mirror on the y-axis, and the whatever view we are going to get in this mirror will be drawn in the second quadrant. Therefore, the folded version of this signal is represented as u of minus t, and this signal will be drawn in the second quadrant. So this signal will be folded along the y-axis and it is going to change its direction towards negative axis with the same amplitude 1. Therefore, this is a simple folding operation. Now let us see one more example. So let's take a modified version of this unit step signal, or let's take, instead of unit step, we'll take some random signal now. So let's say I have a signal of triangular nature with amplitude 1 and 1 in the first quadrant, and I have a rectangular signal with, let's say, coordinate minus 2 in the second quadrant, and let's say this signal is denoted as x of t. And now I am supposed to find out the folded version of this signal, which is denoted as x of minus t. Okay, so let me mark the amplitude 1 with the origin. Now we are supposed to draw the folded version of this signal. So as we know, if we keep mirror on the y-axis, whatever is seen towards right hand side, that is quadrant number 1 and 4, will be folded and drawn in quadrant number 2 and 3. Similarly, whatever is available in quadrant number 2 and 3 will be drawn in quadrant number 1 and 4. So here we have triangular signal in the first quadrant, and if I keep mirror on the y-axis, this signal will be folded and I will get a triangular signal in this way, minus 1. So 1 changes to minus 1. Similarly, I have signal in the second quadrant, again it will be folded, so it will be shifted in the first quadrant and I will get signal as plus 2 with a rectangular signal. So this is how we are going to operate on the signals for the folding operation. So remember here, folding operation means we are going to multiply if I have original signal x of t, in this original equation, I'm going to multiply this t parameter with negative sign. So it is as good as whatever positive axis I'll be having, that positive axis will be converted into negative axis, and whatever negative axis I'll be having, so I'll be multiplying it with negative sign, so minus of minus becomes plus, so this axis becomes positive and positive axis becomes negative. Therefore, whatever is on the positive axis, everything will be drawn on the negative axis. If you look at this particular example, we have one triangular signal from 0 to 1, and if I multiply this 1 with minus sign, it becomes minus 1. So this point is drawn on the negative side. Similarly, here x of t, I have minus 2 parameter with a rectangular signal from 0 to minus 2. So 0 multiplied by 0 remains 0, and minus 2 multiplied by minus sign becomes plus 2. So it is shifted towards the positive side. So in this way we have the folding operation. Now the second operation is time shift operation. Here this operation again has two variants. First, if I have original signal x of t, then I can shift this signal x of t by positive shift, let's say t naught. And similarly, I can have signal x and I can shift it with negative shift t0. So again, let us take a simple example. So let's say we have unit step signal again. This is unit step signal, and now I need to draw a shifted version of this unit step. Let's say I need to draw u of t plus 2. Now see, just simply remember that whenever we have positive shift, that is t plus 2, our signal will be shifted towards negative direction by that amount. So here, if we look at our original signal, it is starting at 0 and it is approaching towards positive side. So we are going to pick up this signal. This signal is being picked up and it will be shifted towards left side by amount 2. So this signal will be picked up from the origin. It will be shifted by amount 2 towards negative side, so that 0 will be shifted towards left hand side because our signal is starting at 0. So this 0 will be shifted towards negative side by amount 2, so it becomes the coordinate minus 2. And as it is, we are going to draw the signal without changing its direction. So in this way, the signal has amplitude 1, it is approaching towards positive infinity, and simply it is shifted from origin towards left by amount 2. Remember, if the shift is positive, signal is shifted towards left hand side, that is towards negative axis. Similarly, if we have the next signal with negative shift, u of t minus 2. In this case, as the shift is negative, we are going to shift the signal towards positive side. Therefore, our original signal starts at 0, approaches towards positive infinity. So this signal will be shifted towards positive side by amount 2. So we are going to mark that 0 is shifted towards positive side, that is the right hand side, by amount 2, and from this point the signal is going to start. So it has amplitude 1 and it approaches towards positive infinity. So remember here, in the previous operation, which is folding operation, our signal was changing its direction. But in case of shifting, signal doesn't change its direction. So if you look at u of t, it is starting at 0, approaching towards positive infinity. U of t plus 2, so signal is shifted towards negative axis, towards left. So origin, every point on this signal is shifted by amount 2 in the negative side. So 0 is shifted at -2 and the same signal is drawn toward approaching towards positive infinity. Similarly, u of t minus 2, signal is shifted towards positive axis. So signal starts at origin, shift this origin by amount 2 towards right hand side. So this 0 is shifted towards 2 and the signal is drawn again to approaching towards positive infinity. So this is the time shifting operation. And the last, third operation is time scaling. So here also we have again the time scaling operation given as, if we have original signal x of t, then its time scaled version is denoted by x of at. Remember here, in this every operation we are always operating on the time parameter. Now here, if the value of a is greater than 1, this operation is called as compression. So we are compressing the signal. And if this a is less than 1, this operation is called as expansion. So let us take an example here. So to understand it in a better way, let's say we have a rectangular signal. Let's say this rectangular signal is starting from -2, ending at +2 with amplitude, let's say 2. This is our, let's say, x of t signal. Now let's say I need to find out the next signal, which is x of 2t. Now remember here, whenever it is x of 2t, the operation is called as, the scaling factor a is greater than 1, hence the operation is called as compression. So in this case, just remember here, here we have this parameter 2 is multiplied with the t parameter. So again do the vice versa operation. Here it is multiplication, so divide the every parameter of time by 2. So x of 2t signal will be like, here in the above parameter, in the given x of t signal, we have the signal starting at -2. So divide it with 2, it becomes -1. Similarly, towards positive side it is 2, divide it with again 2, it becomes +1. And draw a rectangle between these 2 points with the same amplitude 2. So in this way our signal is now compressed. Initially the width of signal is 4 and now the width of signal is 2. So we are compressing the signal in the time parameter. Similarly, if we want to draw the next signal as, let's say, x of t by 2. Now in this case, the operation is now called as expansion. So here it is division. Here we are dividing the time parameter by 2, hence multiply in the original signal the time parameters by 2. So -2 becomes -4 and here we have +2 becomes +4, and signal will be drawn between these two coordinates with the same amplitude 2. So this operation, the width of signal is increasing, hence this operation is called as expansion. So remember here, whenever we are doing operations on time variables, the amplitude of signal doesn't changes. If you look at every operation whatever we have seen so far, all the 3 operations, here the first operation was folding. So on the y-axis we are going to keep a mirror, and whatever is seen towards right hand side is drawn on the left by folding it. So here signal is going to change the direction. In the second operation it is time shifting. If the shift is positive, signal is shifted towards negative axis. If the shift is negative, signal is shifted towards positive axis, keeping amplitude same. Amplitude doesn't have any impact. And in the third operation we have time scaling. So if the scaling factor here it is 2 is multiplied with time, so divide the axis by that factor. Here it is t by 2, so here t is divided, so do the vice versa operation. Here it is division, so multiply the factors, the time coordinates with the factor 2. So in this way we have completed operations on signals for independent variable, that is time.